So in this video, we are going to discuss the measures of central tendency. First of all, what is the meaning for central tendency? Central tendency means a typical value. Typical value means a single value which represents the entire data. That value we consider it is a middle value or central value. So to calculate that middle value or central value, we are using different type of measures. So here we are going to discuss three different type of measures: mean, median, and mode. Mean, arithmetic mean, and average. All are same. So mean, median, and mode are the measures of central tendency what we are going to discuss with this session. So first, we need to identify which measure is the best measure or ideal measure. So based on all these characteristics, we mention one particular measure which satisfying all these characteristics that we consider it is a good measure or ideal measure. So first point, it should be rigidly defined. That means it should be clearly defined. A mathematical definition should be there. Then only we consider it is a good measure or ideal measure. Then it should be easy to understand and compute. It should be based on all items in the data. Its definition shall be in the form of a mathematical formula. It should not be affected much by extreme values. It should be affected as little as possible by fluctuation of sampling. It should be capable of being used in further statistical computations or processing. So if measure which is satisfying all these characteristics, then only we consider that measure is the ideal measure. So we consider with these three measures, not only three, even we have few more measures. In all measures of central tendency, we consider the arithmetic mean or mean is the best measure because that's satisfying most of all these characteristics. So we consider arithmetic mean or mean is the best measure of central tendency. So we have a different type of series when we collect the data and when we present the data or the data when we approach a measure of central tendency. So we have different type of formula. So based on the data series only, we need to choose the formula. So here there are three type of series: raw data, discrete, and continuous. So raw data is the individual terms or ungrouped data. Discrete and continuous or grouped data, and discrete is a countable, but continuous is a range of value will be given that is uncountable. We cannot say what how many values in between two numbers. So we can give one count in between two range of values. That is what continuous. Then mean or arithmetic mean or average. So here the formula of for raw data, discrete and continuous is given. So in this arithmetic mean, we can use discrete series formula for continuous series also. Direct method and assumed mean method is listed for discrete series, and continuous series near direct method, assumed mean method, and step deviation method is mentioned in this slide. So all the three formula can be used for continuous series. So what are the merits of arithmetic mean? So it is rigidly defined. As already mentioned, the arithmetic mean is the best measure or ideal measure. So here we can see most of the points or characteristics of good measures of central tendencies satisfied by the arithmetic mean. So first point is rigidly defined and it is easy to understand and easy to calculate if the number of items is sufficiently large. It is more accurate and more reliable. It is a calculated value and it is not based on its position in the series. It is possible to calculate even if some of the details of the data are lacking. Of all averages, it is affected least by fluctuations of sampling. It provides a good basis for comparison. So these are the merits of arithmetic mean. And we have some demerits for arithmetic mean. It cannot be obtained by inspection, not located through a frequency graph, and it cannot be in the study of qualitative phenomena. Then it can ignore any single item only at the risk of losing its accuracy. It is affected very much by extreme values. It cannot be calculated for open in class intervals. It can need maybe lead to fallacious conclusions if the details of the data from which it is computed are not given. So these are the demerits we face when we approach arithmetic mean. Then combined mean. Combined mean we can use when the original data is not given, but we need to find the combined mean of two different group of people's average. For example, the here we have given two group examples. First group and second group arithmetic mean and the number sample number is given. So combinedly x12 bar, that is what we can call it is a combined mean. So combined mean we can calculate by using this formula. So next measure is the median. Median is also we can call it as a positional average. Raw, discrete, and continuous. We have different type of formula. For raw data, n plus 1 by 2, the observation. The respective observation is the median. Same way, discrete series, capital N plus 1 by 2, the observation. That means the capital N and small n here we differentiate. Like small n is number of term and capital N is the last cumulative frequency. Then the median for continuous series, we have separate formula like n plus n by 2 minus Ef by f into c. So with this, we can calculate median. So merits of median. So easy and simple to calculate, unaffected by extreme values, graphical representation, suitable for open-end distribution, suitable for qualitative phenomenon, further study. So all this we consider it is a merits of median. Then tedious process, unsuitable for even observations, unsuitable for algebraic treatment, unsuitable for fraction and percentages. These we consider it is a disadvantage or demerits of median. Then the next measure is a mode. So mode also we consider it is a, one of the positional average. Also we can identify using graphs. So the main purpose of mode is to find the ideal size. Like for example, in business forecasting, in the manufacturing of ready-made garments, shoes, etc. So which size is sold out more in numbers, so that we for identifying we can use the concept mode. Here also we have three different series. For raw data, usually there is no formula. We just like that the mode definition can be approached to find mode, the most frequently repeated value. That is what we call it is mode. The same definition can be used to find mode in raw data. Discrete data, so frequency is nothing but the how many times a specific value is repeated. So that way we can identify the highest frequency and the respective x value. That means the highest frequency shows the respective x value is repeated more number of times. That way we observe it is a mode. Then continuous series, we have separate formula like L plus F1 minus F0 divided by 2 F1 minus F0 minus F2 into C. Here F1 is the median class frequency, sorry, model class frequency. F0 is the preceding the model class frequency, and the F2 is the succeeding the model class frequency. C is the width of the class interval. L is lower limit of the model class. So merits of mode. Mode is the most representative value of distribution. It is useful to calculate model average. It is not affected by extreme items in this series. It can be determined graphically. The open-end class interval. For the open-end class interval also, we can use mode. It can be located by inspection. Demerit. Mode is ill-defined. It is not based on all the observation. It is not capable of further mathematical treatment. As compared with the mean, the mode is affected to a greater extent by fluctuations in sampling. So these are the demerits we consider for mode. So today we discussed mean, median, and mode. What is the meaning for mean, median, mode, and what are the advantages and disadvantages, and what are the formula we can use to calculate the respective measures. Thank you.